The students at Caltech have a smashing Halloween tradition. At the stroke of midnight, they drop frozen pumpkins off the top of the library, the tallest building on campus. The frozen pumpkins shatter below, leaving a terrific mess. The library building is 44 meters tall, 9 stories high. How long does it take for a pumpkin to reach the ground? If they can drop one pumpkin every 6.4 seconds, how many pumpkins can the students drop before the clock reads 12:01? In case you've been wondering when you would need quadratic equations in real life, here it is. You'll come across this kind of problem a lot in physics. Dropping things, throwing things. If you want a real thorough grounding in quadratic equations, we have a free mini course all about them on our website, Socratica.org. You can find the link below. Now, here's the quadratic equation that physics students everywhere know and love. The height of an object, t seconds after it is dropped, is given by the equation h equals -1/2 g t squared plus h0, where h0 is the initial height and g is the acceleration due to gravity. On planet Earth, g is 9.8 meters per second squared. For this spooky situation, we're looking at two different heights. h0, the initial height, is 44 meters. h, the final height, is 0. Splat, right on the ground, 0 meters. So we can substitute in what we know. 0 meters equals -1/2 times 9.8 meters per second squared times t squared plus 44 meters. There are quite a few different methods to solve quadratic equations, including factoring, completing the square, and using the quadratic formula. But lucky for us, this is one of the more straightforward examples of quadratic equations that we'll solve by taking the square root of both sides. You can use this technique if the equation can be written in the form x squared equals n, where there is no x term. Take another close look at our equation and assure yourself that this will work. We have a t squared term and no t term. Now, we want to get t squared on a side by itself, so we can solve for t. Subtract 44 meters from both sides. -44 meters equals -1/2 times 9.8 meters per second squared times t squared. Multiply both sides by -2. -2 times -44 meters equals -2 times -1/2 times 9.8 meters per second squared times t squared. 2's cancel, giving us 88 meters equals 9.8 meters per second squared times t squared. Divide both sides by 9.8 meters per second squared. Meters cancel, giving us 8.98 seconds squared equals t squared. Now, take the square root of both sides. Every square root has a positive and a negative answer, so you get t equals plus or minus 3 seconds. But there's no such thing in this universe as negative seconds, so your answer is t equals 3 seconds. How many pumpkins can the techers drop in the 60 seconds between the stroke of midnight and 12:01? It takes 6.4 seconds per pumpkin drop, so we can calculate in 60 seconds times this conversion factor, 1 pumpkin per 6.4 seconds, seconds cancel, equals 9.375 pumpkins. Now, Caltech students are very clever, but do you think they can drop 0.375 of a pumpkin? No. You need to round down here to a whole number to get 9 pumpkins. I wonder if there's any way to improve on this Halloween pumpkin drop tradition. I know. If we moved it to the moon, let's get Caltech to build a second campus there, where the acceleration due to gravity is about 1.6 meters per second squared. How would that change our answer? If we keep everything else the same and just change g in our equation, h equals -1/2 g t squared plus h0, now we get 0 meters equals -1/2 times 1.6 meters per second squared times t squared plus 44 meters. And we'll solve this problem in a similar way. Subtract 44 meters from both sides. -44 meters equals -1/2 times 1.6 meters per second squared times t squared. Multiply both sides by -2. -2 times -44 meters equals -2 times -1/2 times 1.6 meters per second squared times t squared. 2's cancel, giving us 88 meters equals 1.6 meters per second squared times t squared. Divide both sides by 1.6 meters per second squared. 88 meters divided by 1.6 meters per second squared equals t squared, which gives us 55 seconds squared equals t squared. Take the square root of both sides to solve for t, and the one positive answer is 7.4 seconds. Now that's enough time for a good countdown. 1 pumpkin, 2 pumpkin, 3 pumpkin, 4 pumpkin, 5 pumpkin, 6 pumpkin, 7 pumpkin, splat! Now, it's your turn. Let us know in the comments below, does the second part of the question, the number of pumpkins dropped in 1 minute, change on the Moon campus? Why or why not? If word problems give you the chills, even when it's not Halloween, we can help. We have a whole playlist of word problem videos. And as a special way to take care of our Socratica students, I wrote a book for you, How to Solve Word Problems. Get your copy today, watch our videos, and have no fear.